In this lecture, we'll look at whether or not we can predict tsunami and how we can mitigate and reduce the damages from tsunami events. The image here is from June 2017, when there was a tsunami in Greenland after a massive landslide triggered a 300-foot wave that devastated a nearby village, including washing away some of the houses. We cannot really predict the events that trigger tsunami, such as earthquakes and landslides. However, we can monitor changes in water levels that can help determine if something unusual is happening in the oceans. The huge toll of the 2004 Indian Ocean tsunami led to a globally coordinated effort to monitor ocean waters for potential tsunami activity. For the US Tsunami Warning System, we went from having 7 to 60 deepwater ocean buoy systems. We now have over 230 coastal systems that can also provide similarly detailed water level information. We staff our warning centers 24/7 rather than just a regular work week. We have 5 times as many partners in our programs, and the number of communities who have developed tsunami-ready programs went from 14 to almost 200. The main feature of the global warning systems are the DART buoys. The DART system deploys a series of specially sensitive buoys. These have sensors on the bottom of the ocean that detect small anomalies in water level using pressure differences. These signals are transferred through the water to a surface buoy, which can then transmit the information to satellites and on to research centers. These buoys cost hundreds of thousands of dollars and require periodic maintenance. Data for the DART system is archived for the long term at the United States NOAA National Center of Environmental Information. There are about 50 DART buoys around the world. Data from the DART buoys, as well as other water level buoys, are used in models to predict the arrival times and wave height and trigger warning systems. The warning system was effective in Japan 2011, where it was given 3 minutes after the earthquake happened and 17 minutes before the tsunami arrived. The warning was for 3 to 6 meter waves, but they actually turned out to be 10 meters high, reaching up to 50 meters in some places. But even with the DART system in place, there are still failures, such as the 2018 Indonesia tsunami. In that case, there were 22 early warning buoys in place, but none of them were working. The nearest tsunami water level detection system was 200 kilometers away, too far to be useful for the Palu Bay area. Warnings are issued after an event that might create a tsunami. Even when no tsunami is indicated, this information is also shared. This map shows the location of 3 recent events that had the potential to produce tsunami because they were relatively large earthquakes. For example, the earthquake in Alaska on Sunday, September 13th, led to this notice that a tsunami was not expected. So warnings and some advance notice can help people get away from an impending tsunami, but there's more we can do to reduce the damages. There are a wide range of potential tools that can help mitigate the damage done by tsunami. We'll briefly touch on each of these. These are examples of some of the signs that you might see near an area at risk of a tsunami when proper planning has been done. These signs are part of education and awareness. There is another great example of that from the 2004 Indian Ocean tsunami, where a schoolgirl on holiday from England helped save people on the beach when she recognized that the extra low water level was an indicator of a tsunami, as she had recently learned in geography class. Probability analyses assess the risk of a tsunami, as shown in this map. You can see that most ocean coastlines are at some level of risk, as well as some lake shorelines. Some areas are more at risk than others. The areas at greater risk are those located nearer potential sources. The major tectonic plate subduction zones represent the greatest risk and highest chance of large underwater rupture. Note that this is primarily the region around the Pacific Ocean. Engineering solutions to tsunami waves always exist, such as building barrier walls. Barriers are often constructed, such as we saw in the video for the Japan tsunami and shown here. These can stop tsunami waves that are smaller than the wall, and even with large waves, they can slow them down. But some experts think that these are really just more dangerous. They can create a false sense of safety. If the tsunami is large, the barrier wall can be breached. These walls can also make it hard for the water to drain afterwards, increasing the risk of secondary effects. Land use planning can be an effective way to reduce the impact of a tsunami. In Huntington, California, the town has a pretty low elevation. 3/4 of the town is below 25 feet in height. It also faces south and west, so it is susceptible to events that could be initiated in Alaska, Japan, and the South Pacific. The beach attracts up to 100,000 people per day in the summer. To help identify the areas most at risk, the town developed a run-up map for a 5-meter tsunami. This helps determine the places that it might be safe for people to retreat to in a tsunami warning and to plan appropriate evacuation routes. Because the potential starting locations are relatively far away, a tsunami warning should provide enough time for people to leave the beach. Clearly, some neighborhoods would be impacted. New construction in these areas could be done to make the buildings more resistant to tsunami damage. Construction in a tsunami-prone zone is much more likely to withstand the wave if it is raised so that the water can flow underneath rather than push the building off its foundations. Here are some examples of houses that were built in Indonesia after the 2004 tsunami, and one that was a remodeled 1940s era home on Puget Sound in Washington State. However, many areas do not have houses that would be appropriate for a tsunami. This is because local building codes were not designed to take into account the risk, which is often perceived to be relatively low. Recovery from tsunami offers new opportunities to improve construction and land use. Here you can see some images of before and after the Japanese 2011 tsunami. The land use that had previously been used for homes and other buildings was replaced with berms and young trees that will hopefully grow into a forest that provides some protection by absorbing the initial energy of the wave. In other cases, the land is now being used for solar panels that are raised above the ground. Recovery from tsunami is not easy, and in some cases may never fully occur. In Banda Aceh, after the 2004 tsunami, aid organizations helped rebuild so that people could return home. However, many survivors chose to move inland rather than continue to live on the coastline. So low-income newcomers ended up renting the rebuilt houses. Now the lower-income residents are disproportionately exposed to the coastal hazards. The poverty rates pre-tsunami had been relatively low and stayed low even after the tsunami, but only in the central and inland areas. In the tsunami-affected area, poverty rates went up after the tsunami and have remained high. These data show that there can be long-term exacerbation of poverty and inequality after a tsunami event. So what have we covered? A global water level monitoring program can help provide advance notice of tsunami in many cases, potentially saving people's lives. Damages can also be reduced by many other mitigation strategies. Thus, although we cannot prevent tsunami from happening, we have opportunities to reduce the damage that can occur.